let's look at summation notation. So the sum of the first n terms of a sequence is represented by, this is sigma here, n, and then I equals 1, ai, and those are the terms here, and you're adding all of those terms together up to that nth value. Now, just to define it a little bit more, I is the index of summation, and then n is the upper limit of summation, so it goes to that point. 1 is the lower limit of summation, so this is where you start, and this is where you end. So summation notation is an instruction to add the terms of a sequence. Note that the upper limit of summation tells you the last term of the sum. Summation notation helps you generate the terms of the sequence prior to finding the sum. Okay, so in the homework, you're going to have to write a sequence or a series here in summation notation, so just notice where the first term is, the last term is, and that will help you out. So we're going to find the sum given summation notation, and so we have here 1 is our lower limit, 5 is our upper limit, and we have 3i. So what we can do is we just plug it in. So 3 times 1 plus 3 times 2 plus 3 times, and you keep on going up until the upper limit. 3 times 4 plus 3 times 5. So this is 3 plus 6 plus 9 plus 12 plus 15. And then you find that will be 45. And so you do the same thing here. Now here we start at 3. So therefore it's 1 plus 3 squared plus 1 plus 4 squared. And then 1 plus 5 squared plus 1 plus 6 squared. And then you get 10 plus 17 plus 26 plus 37. And that is 90. So go ahead and try C, and then also try the bottom value, the bottom you try to see if you can find the sums. So for letter C, if you tried it out, you would have hopefully written these down. So you start at 0, right? So 1 over 0 factorial, remember that's just 1, and then you keep on going until 8 factorial in the denominator. And so then I converted it to fractions here, and when you actually add it all together, you notice you'll get approximately 2.71828, which is approximately E, so very interesting. The next example here, if you tried this out from 1 to 4, you would have hopefully gotten 44. So here are some properties of sums here just to kind of take a look at it. Although I don't think in the homework you are using it, but this is how you could do it. We could separate things out. So you have the I here. Notice that we could just add the two sums together instead of doing it separately, right? So just kind of some formulas to have. And then series, so definition of a series. So many applications involve the sum of the terms of a finite or infinite sequence. And such a sum is called a series. So consider the infinite sequence A1, A2, A3, and then AI. The sum of the first terms of the sequence is called a finite series, or the nth partial sum of the sequence. And so it'll tell you it starts at A1 perhaps, and then it goes to that nth term, so the first terms. Then we have an infinite series. So you notice up here is infinity, okay? And so let's try these out, finding the sum. So we're going to find the sum of a series. So given this series, find the third partial sum, and then B, find the full sum. So to find the third partial sum, we're going to take a look at I equals 1 to 3, and then we plug it in. So 3, 10I, and so let's start. 3, 10 to the first plus 3 over 10 squared plus 3 over 10 cubed. And so that will be 0.3 plus 0.03 plus 0.003. And what you find, that is 0.333 in this case. Okay, so let's try to find the sum. So this is I equals 1 to infinity. And then we have 3 over 10 to the I. And then you plug it in. And so I hope you see that you're going to get these same values here. So this is 3 over 10 to the first plus 3 over 10 squared plus 3 over 10 cubed plus 3 over 10 to the fourth plus 3 over 10 to the fifth. And then it keeps on going forever. So we already know that this is 0.3 plus 0.03 plus 0.003, and then it keeps on going. And then dot, 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 dot. And then if I add these all together, notice I'm going to get 0.3333, and it keeps on going. And then that is really 1/3. We will get some formulas for that. So try out here, find the fourth partial sum, and then the sum here. If you can figure out how to write it in fraction form, that would be great. But if not, that's okay. If you can at least get the decimal, that's okay for now. Okay, so the fourth partial sum, you should have gotten 0.5555, and then here you would have gotten 0.55555, and then it, of course, continues on forever. And then there is a formula that you can use for the, to change this. It's S equals 0.5 over 1 minus 0.1. This is a sum of an infinite series, which we will talk about in a later chapter. But this is how you would write it in fraction form. But if you at least got to here, that's okay. I just noticed in example 9 that the sum of an infinite series can be a finite number.